Good morning children, Sairam. Children, welcome you all in this physics video where we are having our chapter number 10, refraction of light, and this is the fifth part. Children, in this video you will learn image formation by convex lens. There are total 6 cases for convex lens, and the first case is when the object is placed between optical center O and focus. So, wherever object is placed here, it is placed between optical center O and focus. This is our object AB. So, when we are placing object in front of convex lens between O and F, then the refracted light rays, they are not meeting at any point. So, what we are doing? We are just producing them. And where they are meeting behind the object. They are meeting behind the object. The image is erect, it is up straight, erect, and what will be the size? It is magnified. So we can write down the nature here, virtual and erect, size is magnified, and position is behind the object. So now the second case is when the object is placed at the focus. Children, in this case, our object is placed at focus and the refracted rays are going parallel. They are parallel, and these two parallel lines are showing that image will form, but it will form somewhere at infinity. So in this case, nature will be real and inverted, size will be highly enlarged, and position will be at infinity. The third case is when the object is placed between F and 2F. Now in this case, you can see clearly object is placed between F and 2F. This is our object. And the two refracted rays are meeting, where they are meeting beyond 2F. This is our 2F point. Size is larger than the object, it is magnified. So we can write down the nature is real and inverted, size is magnified or larger than the object, and position of image is beyond 2F. Case number 4, when the object is placed beyond 2F. So this is our 2F point and we are placing object beyond it. Now the two refracted rays are meeting, where they are meeting between F and 2F. So this will be the position of image, and size, if we are comparing, it is smaller than the object. So we can write down nature is real and inverted, size is smaller than the object, and position is between F and 2F. Next is number 5 case, when the object is placed at infinity. Children, in this case, when the object is placed at infinity, we cannot show object. We are just showing the rays which are parallel. Okay. So these are the parallel light rays which are coming from the object, and where they are meeting at focus point. They are meeting at focus point. So in this condition, nature will be real and inverted, size will be highly diminished, and position will be at focus. Now the last case is case number 6, when the object is placed at 2F. In this case, the image will be real and inverted, size will be of the same size, and position will be 2F. Means object position is 2F and position of image is also 2F. This is our object. It is at 2F, and where the image is forming, it is again forming at 2F. But where? On the other side of lens. So in this way, we have finished our 6 cases for convex lens. Now uses of convex lens. Convex lens is used to correct the defect of eye that is known as long-sightedness, or it is also known as hypermetropia, in which a person is not able to see the nearby objects clearly. Number 2 is it is used for making simple camera, for magnifying glass, and also in case of microscope, telescopes and slide projectors. Now we are coming towards the concave mirror. It is also having two cases. The case 1 is when the object is placed anywhere between O and infinity, means optical center and infinity. Children, in case of concave mirror, the concave lens, the image will always be diminished. Right way up means erect and virtual. So here you can see how the image is forming. The light rays are going in this way. They are getting refracted. The other rays and going in this way. So where they are forming, if we are producing this ray, they are form image here. So in this way, we can say that image is virtual and erect. Size will be highly diminished, and position will be behind the position will be in front of concave lens. Case number 2 is when the object is placed at infinity. In this case, again, object is placed at infinity, means image will form at focus. So image will be forming at focus. This will be the position of image. Size will be highly diminished, or it will be point size image. Now the uses of concave lens. Concave lens is used in spectacles to correct the defect of vision, myopia. Myopia in which a person is not able to see the far objects. It is also used in spy holes in doors and also in telescopes. Now children, lens formula. Earlier you have learnt about mirror formula. What was mirror formula actually? It was 1 upon f is equals to 1 upon u plus 1 upon v. But now if we are changing this sign, plus as minus, then it converts into a lens formula. So lens formula is the formula which gives the relationship between object distance u, image distance v and focal length f of lens. It is known as lens formula. And this formula can be written in this way: 1 upon v minus 1 upon u is equals to 1 upon f. Next is magnification of lens. This also you have learnt in case of mirrors also, but here we are having slight difference. Magnification is the ratio between height of image to the height of object, or we can say it is the ratio between image distance and object distance. So we can write down the formula of magnification as hi upon ho, or it is also equals to v upon u. Now we are having another topic, that is power of a lens. The power of a lens is the reciprocal of its focal length. So if we want to write down the formula for power, that is P is equals to 1 upon F, where M will be in meters. Okay, or we can write in other way also, that P is equals to 1 upon, F is equals to 1 upon P. The unit of power is diopter, which is written as capital D in shortcut. And 1 diopter is the power of lens whose focal length is 1 meter. The power of convex lens is always positive and the power of concave lens is always negative. Now, the home assignment, what is lens formula? Where an image is formed when an object is placed at focus in front of a concave lens. Write 2 uses of convex lens. Children, it is by mistake, it should be S. And next is write 2 uses of concave lens. So in this way, our topics are finished today. Thank you, Saira.